welcome many of you to Toronto, Canada. Ladies and gentlemen, introducing Dr. Ryan Jansen.
Thank you. Thank you, and thank you everyone for coming here, for being here. Is everyone comfortable? Yes. Okay, good. And well, I'm looking forward to, and we're all looking forward to sharing just a little bit of what we've been working on. Innovation, true innovation, always starts with an idea. And it's often just a shadowy wisp of an idea kind of floating out there, hard to put your finger on. But once you know you have it, you have it. And if that idea is nurtured, if that seed is kind of given a space to grow, it can grow to something truly massive. Tonight, that innovation is about high-speed vehicles and tackling our climate crisis. You're going to actually see some things and actually touch something new to this world. Tonight, what we're announcing is something we can call the FluxJet. We've been quietly working on ultra-high-speed transportation, but what the world hasn't seen so far at all is what we've been really working on behind the scenes and what we've been developing. So this is what it looks like. The FluxJet is different from an aircraft, and it's different from a train. It's a whole new type of vehicle, a new category. And this is a vehicle to carry passengers between cities at over 1,000 kilometers per hour, and cargo and freight. But it operates slightly like a train, and it's built like an aircraft. And so here is the basic idea. And this is what we call a FluxJet line. Traveling along this line will be a little bit like going in a subway or a high-speed train, but much faster. And I'll talk about the construction plan of that later. But okay, wait, why is it called a FluxJet? Well, we're bringing together three innovations. These are major innovations. We're actually bringing together three different kinds of flux. The first here is called valence flux. That's to safely guide this vehicle at high speed. The second is magnetic flux, and that's actually to levitate the FluxJet and push it forward. Now the third flux in the blue is electric flux, and that's to get power onto the vehicle. All three of those types of flux are with no contact, kind of like this. Because friction is the enemy of speed. And so everything about the FluxJet is designed to avoid friction. So those three things, electric flux, magnetic, and valence flux, working together, and that is a first. Electric, magnetic, valence. EMV. The world's first EMV FluxJet. FluxJet for short. So let's just take a quick tour of those three fluxes. And this is really beautiful. Of the three different fluxes, the first one is electric flux. And what's exciting about that is that we're using plasma to get power onto the vehicle. What the heck is plasma? Well, has any of you seen the Northern Lights? Let's just take a look. This is something that we see sometimes in the far north at night. They also see it in the southern hemisphere too. It's a natural phenomenon. It's called the aurora. And that's actually plasma up there. And so it glows. Now you might remember as a kid, you have solid, liquid, gas, those three states of matter. But then there's a fourth one called plasma. And so that's plasma. You also have plasma out in deep space, out across galaxies. So there's plasma in stars and in nebulas that form new stars. The FluxJet is harnessing plasma to make it work. And that is groundbreaking. Well, how does that work? Well, think of a train. So trains touch, right? So sometimes you have electric trains. So electric trains, they have a piece of the train that touches maybe either a rail or a wire, and that gets power onto the train. What's different about a FluxJet is it's using plasma to get power onto the vehicle without touching at all for the high speed. And it looks just a little bit like this. So this is just a very small model, and it's chopped. So this is just a chopped up version, just a little thing to show you. And so they're just dimming the lights. You can actually see plasma here. So right now, it's getting power onto the, see these lights here? So and we have the voltage display somewhere. So it's getting power onto the vehicle right now. The power is coming from the grid, okay, from the grid, going onto the vehicle. And so it's a circuit. So the current goes onto these power rails, goes through that gap. It's not touching. It's going through that first bit of plasma there. It's going into the vehicle's systems, powering things up, going out the other side with this other gap of plasma, and then back again. So that makes a circuit, but a circuit without wires, at least in those gaps. So the wires go here, but then the rest of the circuit here is without wires. And so that is a groundbreaking new innovation for part of this to make it go at high speed. And so you can actually see that, so that's just a little thing, but you can see that at high speed in real life over here. So this is from actually 4 years ago. So this is one of the high-speed tests that we were doing. This is actually recreating the conditions of a NASA experimental aircraft, high speed, high voltage, and so some high-speed tests. We proved this 4 years ago, and the technology has come a long way since then. So we've been working with research labs. We're just starting another project with CERN, the particle accelerator in Europe. So that whole team. And you can actually see that on the FluxJet vehicle too. So let's just take a look. So here's the FluxJet. Okay, it's going along there. So it already has auxiliary power, secondary power. Once it gets up to a certain little medium speed, you see that special technology deploying. So that power pickup, now we see the plasma there. So it's getting power from the grid onto the FluxJet. And now it can start accelerating up to that very high speed. And then it goes. So we're taking forces in nature and we're harnessing them. Now, we have the energy on the vehicle. Okay, good. Now, how do we use that? We're going to use that energy to push the vehicle forward, to propel it forward. And actually levitate. So it's going to levitate off the bottom, and so to remove friction. So the second of the fluxes, that's what it's using, and that is magnetic flux. Now, on the vehicle, the FluxJet, there are some fancy engines. How do they work? Well, so they work by creating that wave. They make a wave. And that wave, it's a tiny magnetic field. It's just a small wave that's moving along, but at high speed. And so with that moving wave, that can levitate the vehicle and push it forward. So we're actually controlling and sculpting that wave. And that moves the vehicle. And so you can actually see that over here. So over here, now this is just a really stripped down, simple just to show you the concept. My hand feels nothing, but I can still start to feel this vibrate. Okay, so what's going to happen? Let's try an experiment. I'm going to not push it at all. I'm just going to drop it like this. Whoa! So it just goes along like that. So this is a very crude way of showing it. Very crude, kind of simple toy, very shrunken down version, but that's the basic idea. And ultra simplified. So that's the magnetic wave. Now the third type of flux, just getting to the third one, is called valence flux. So we're just putting these three things together. Sensing, and seeing sight. Sensing of sensing itself. It's kind of meta. We have some secret sauce for the world's first predictive suspension system. Predictive suspension. Think of your car. So in your car, you have a suspension, right? And so then that keeps the car going smoothly while you're driving along. And usually that's a passive suspension. There's this new thing called an active suspension too. But this is the world's first patent on a predictive suspension. And so that's ultra critical. When you're going at over 1,000 kilometers per hour, that predictive suspension is needed. It's essential. And now we have that. So to sum up, valence flux is for safety and for a smooth ride for the passengers. So that's the FluxJet. So valence flux, magnetic flux, and electric flux. We've spent the last 5 years developing and researching and testing this technology. And it all goes to make this new type of vehicle, the FluxJet. And you think of green transportation, so that's the key here. Green transportation, it's electrically powered and fossil fuel free. That's the point. This is a big project, so ongoing right now as we speak. So developing the vehicle and the infrastructure. So the infrastructure, we're working with construction companies on all of the route planning and so on. It's a massive project that's happening right now with manufacturers, research labs, and universities from around the world that are participating and contributing to this project right now as we speak. We have experts from many different disciplines, many different areas of engineering, construction planning, some of the vehicle control, all kinds of disciplines. It's a very multidisciplinary project, and that's great. And when you have such a wide scope that's being brought together and coordinated, it's very multidisciplinary. You really have to think kind of Leonardo da Vinci, and be inspired by that multidisciplinary spirit. And da Vinci himself was inspired by Vitruvius, who gave us these timeless principles of durability, usefulness, and beauty. You can see the Latin right there. Durability, usefulness, and beauty. And that is that renaissance of creativity I was talking about. So tonight, most of all, I want you to see what creativity and innovation can do, where industry, scientific research, and creativity come together to build something that is durable, useful, and beautiful. So, let's see the FluxJet. Ladies and gentlemen, a baby FluxJet. This here is about a quarter scale model, so of the full FluxJet. This thing has, it's an amazing piece of technology, just this one. It actually has 8 engines on it, so 4 on the top, 4 on the bottom, and so you see one of them here, one of them here, and so the 4 on the top are for guidance and levitation. The 4 on the bottom are for propulsion, and so it pushes it along and making that wave motion. And so all of those engines, you see, are extending out, so they're robotically kept in place like that, and they're held in place kind of like this, and they're all interacting with the guideway, and that keeps the vehicle so that it can actually be controlled. It can actually roll and bank into a curve, like when you're flying on a jet, when they bank the aircraft. And so they all work a little bit like an octopus. Think of it like an octopus with 8 tentacles. So all of those engines working together. This thing actually has 11 computers right now. So 11 brains working together. 8 of those brains are for the 8 engines. And so you can take each of those engines, they can work together or independently. And it's very real-time control, very high-speed control. So of the 11 brains, there are 2 more brains for communication and guidance, and then there's 1 brain to command and control all of the other brains. So 1 brain to rule them all the other 11. So this has a liquid circulatory system going through it. So there's liquid like coursing through the veins in your body. And so the liquid is coursing through this to cool the different systems. Now, this one demonstrator, so we were running this at a different site, and so we basically picked the whole thing up and plunked it down here just so you can actually see and come up and touch it. So this is a very rare opportunity to do it while it's out of service, and you can actually see that. And so what we're going to do, they often talk about the yellow line, stand back from the yellow line. So today, there is no yellow line. So we've stripped things away so you can actually walk up to this and touch it after. So right now, it's operating for safety. It's operating in levitation-only mode. So let's try the levitation-only mode and get that started. And so what's happening here is it actually has magnetic gaps in here. So what I'm going to do, there we go. Okay, I'm actually going to get up here so you can see. Now let's just look at those gaps. So I can stick this piece of paper in here, and so let's just get that there. There we go. Okay, so there's a gap there. So there's no contact. So it's controlling in real time and lifting this 1 ton of weight. The whole thing weighs 1 ton. So it's like lifting up your car on a very smooth cushion of magnetic waves. You see how it's stabilizing itself. So at high speed, we need that stabilization, all working in real time to just guide it smoothly. Let's also see the computer vision. So right now, if they can bring that up on the screen. Oh yeah, there we go. Okay, so if I wave this, okay, so it's covered in sensors all over. So I'm just waving the hello. I wave at the front of there. Okay, this is the front, that's the back. So this is just one of the, there's one of the sensors. See all the computer vision, so it's tracking tracking the guideway in real time. And the whole thing is covered in sensors, so I think at last count it was about 230 sensors just on this thing. So 230 sensors. Compare that to the full FluxJet vehicle. It's incredible the amount of control and communication that's going on. And speaking of that, I sometimes talk about it like a set of Russian dolls. So you have the small one, and then right now we're also working, there's a half-scale test facility that we've got the construction permit for in France. So that's going to be next year. Then we're, meanwhile, right now, working on the full-scale test track, and you're going to hear about that in a moment, in Alberta, Canada. So it's all of this being developed by us and our partners at the same time. And so, okay, what about the passengers? When Boeing and Airbus build a new jet, they always design it to be reconfigurable. So every different airline has their own preference for how the seats are laid out. They all make their different forms. And so that one's old. A little bit newer is two of our ones where we have the economy version and the business class version, different versions of the interior. The economy class version has 54 seats and the business class 34 seats. So one of the amazing things here is we have a special design to make this fully accessible. So this is a fully accessible vehicle, the FluxJet. Think of people who are in a wheelchair. With this fully accessible vehicle, that's part of the passenger experience that we've been designing. So that's a first. And so the whole line is called a FluxJet line. And so it's not only the vehicle, but it's also the infrastructure. So we've been working with construction partners and civil engineering firms, architecture on all this, the infrastructure design, station design. This is being designed for different countries, different cities around the world. And so I'm going to give just one example first, just one example of a location, and that is in Alberta, Canada. So that is that test track, the second test track for the full regulation that I mentioned, where we're going to have regulators from Europe coming, which we're already working at, to inspect that line for the final certification, and of course Canada and the US. That's going to be in Alberta, and so I'm just going to show you, let's just see some of what's coming up in Alberta.
The FluxJet is an exciting, major project that will put a global spotlight on Canada and Alberta. My name's Terry Parker. As the Executive Director of the Building Trades of Alberta, we represent more than 60,000 skilled trades professionals in pipe fitting, welding, carpentry, ironwork, electrical, and much more.
The FluxJet is a bold innovation. I'm Mustafa Shaheen, Edmonton Global's Executive Vice President. Alberta contributes $330 billion to the economy of North America, and Edmonton is Canada's fastest growing region. As Western Canada's manufacturing and logistics hub, we are strategically connected for international trade.
We look forward to participating in new industries and bold new projects that revolutionize transportation as we know it, to help us reach our net zero goals by 2050. The TransPod FluxJet line is that project. Our workers handle billions in construction work each year, and the TransPod line is ideal for construction at a mass scale.
The TransPod FluxJet line is an exciting project that will enhance regional connections and accelerate transportation at a massive scale.
The FluxJet is a bold leap forward in technology that we're incredibly excited about and to be part of.
Now, you may have heard the news, the infrastructure investment that we announced back in March. That is just the first step. So the total Alberta project is $18 billion. That's to construct the full-scale line from Calgary to Edmonton. So the full line. And I can now announce that that project that you may have heard about in the news is going to be a FluxJet line. So the first phase is construction of a short section, about 15 kilometers, to serve the Edmonton airport. So serving the airport, but also as a test facility, a test track for high speed and for regulation and certification. And the final phase is to construct the full length, the full 300 kilometers between Calgary up to Edmonton with station stops in between. And that location is just one example. So we have projects planned in other countries with government leaders in the USA, France, Italy, and the UAE. And you'll be hearing more about those soon. But let's just think about, okay, what is it like for you? let's just see a little bit of what it's like to ride in a FluxJet line. So we see here the scale of that small demonstrator there, but then this is the full FluxJet vehicle that we're designing right now in parallel. It's about the length of a train coach, actually, and it's like an aircraft. And so here is some of the blueprints at a station. So let's just see. Now, at a station, think of when you fly in a jet. You have to book your ticket for that exact day, your plane ticket for that exact time. You can't just show up at the airport whenever you want, right? With the FluxJet, you just show up at the station, kind of like a subway, show up whenever you want, pay for your ticket, and wait for the next vehicle. And one special thing about this, too, is it's 2 parts. So the first part is for local transportation in a city, so to relieve mass congestion, so traffic congestion. So it's a public transportation system, station downtown, other stations around the city towards suburbs and airports and so on. So that's for local and regional transportation. And that's at a moderate speed. Now, when we get to the edge of the city, you see it go into this little building here. And so that's to transition it to get ready to go into the high-speed zone onward to the next city. And so it's ready, and so now it's going to start accelerating to get up to it's gradually up to its full speed. Okay, so here we see it beginning to get up to speed, just beginning. And so what do we see? We see that special plasma technology where we're controlling the plasma and monitoring it and cooling it and so on. So there's a lot of things going on to really maintain and harness that force of nature to get power onto the vehicle, right? And now, so now we have primary power to the vehicle instead of secondary. Okay, so now we're switching to primary mode. We see those engines extending. Now we see those waves, those magnetic flux waves going along there. And so that levitates and pushes the vehicle. We sculpt those waves. And so then now all of these control systems, all those sensors I was talking about, valence flux and so on, you see the extra landing gear retracting. Okay, now it's just about ready to start accelerating to full speed. And then the valence flux, this is just, it's more than just sensing, but it's sensing of sensing. So we'll get to that. But it's all of these systems working together. That's what we're working on with all of these partners. Now, this system, it's not just for one country or one city. Since we are working with many different governments and regions around the world, we are customizing the line for different terrains. You saw forest, you saw desert there for those different locations, different partners, different geography and landscape. As a passenger, when you get to full speed, you're coasting there. You just coast along, read a book, and then you start to decelerate as you get close to the next city. And working with all the ecology and constructability, it's a huge project, both on the construction side and also the vehicle development side. It's a major undertaking that we are doing with industrial partners around the world and research institutes and universities around the world, bringing all of those areas of expertise together right now. As we speak, it's all coming together to make this FluxJet.